So recall last time that we were talking about truth tables. So now we're going to talk about logical equivalence. And so, for example, let's say I say 6 is greater than 2. And then I say 2 is less than 6. Really, these two statements are really saying the same thing, just in a different way, say the same thing. So let's kind of explore that a little bit more. Let's look at a truth table. So let's look at the truth table for P and Q. Okay, so I have two variables, P, Q, which means I have 4 rows in my truth table. And then remember how P and Q works. They both have to be true. So it's true in the first row and false in the other 3 rows. Now, what if I compare this with Q and P? We know that this means essentially the same thing, just a different way of saying it. Well, even if I change the order, Q and P, they still both have to be true in order for the and to be true. So you get true, false, false, and false. So notice here that if I look at these 2 columns in the truth table, these columns are the same. They're identical. So this leads us to the idea of what we're going to call logically equivalent. So let's write the definition. 2 statement forms are called logically equivalent. Logically equivalent if and only if they have identical truth values for each possible substitution of statements for their statement variables. So what this means is that they have to have the same columns in the truth table, okay? So if we have 2 statement forms, let's say P and Q, the way we denote logical equivalence, P is logically equivalent to Q. So we use these 3 horizontal lines to denote logical equivalence. So let's look at an example. Let's see. Let's do P. I'm just going to have 1 variable. So that means I only have 2 rows in my truth table. And let's do not P. So what do? We flip the column for P. So now it's going to be false, true. And then let's take not P. So you're going to flip the columns. The second column, you're going to flip all the entries. So it'll become true and false. And now if you look, the first column and the third column are identical. So what that tells us is that P is logically equivalent to not P. So there's an example of logical equivalence.